Okay, so now we're gonna do section 2 of stoichiometry, which is called limiting reactant and percent yield. Okay, so basically, remember, stoichiometry is a calculation in which which that's what we were doing before, and you can predict how much product you're gonna be able to make. Okay, so just based on your ingredients, like for example, like the example that I gave for stoichiometry, making s'mores. If you were to go to the grocery store and you buy a box of graham crackers, and the graham crackers comes with 24 graham crackers, right? Based on those graham crackers, based on having 24 graham crackers, how many s'mores are you going to be able to make? You're only going to be able to make 24 s'mores, right? Because each s'mores requires 2 graham crackers. So if we have a total of 24 graham crackers, we're going to only be able to make 12 s'mores. So we use stoichiometry to predict how much product we're going to be able to make. Okay, but there's two things here. There's something called limiting reactant and excess reactant. Limiting reactant, remember the word reactant, those are the things that go in front of the arrow. Those are your ingredients. That would be your graham cracker, your chocolate, your marshmallow. So limiting reactant or reagent, same thing, is a reactant that is completely used up. It does not allow more product to be made. So your limiting reactant is what stops the reaction from happening, from making more product. Something called the excess reactant, that is going to be the reactant that is left over in a chemical reaction. So if I go back to the s'mores problem, okay, and I buy a box with 24 graham crackers, and then I also buy a box of chocolate, but that box of chocolate only has, or not a box of chocolate, let's say marshmallows. I have 100 marshmallows and 100 chocolate pieces. Okay, so I went to Costco and I bought a bunch of marshmallows, I bought a bunch of chocolate, but my graham crackers, I only bought 24. Okay, how many s'mores can I actually make? So based on the graham crackers, right, you remember that a s'mores, we're gonna need 2 graham crackers, 1 marshmallow, and 4 chocolate pieces. So based on the amount of graham crackers that we have, we're only gonna be able to make 12 s'mores, because I need 2 graham crackers for every s'mores. So with 24 graham crackers, I can make only 12 s'mores. With 100 marshmallows, I'm gonna be able to make 100 s'mores, and with 100 chocolate pieces, I'm gonna be able to make 20. And with 100 chocolate pieces, I'm gonna be able to make 25 s'mores, right? Assuming that we put 4 chocolate pieces per s'mores. So in this case, even though we have enough marshmallows to make 100 s'mores, and even though we have enough chocolate pieces to make 25 s'mores, we can only make 12 s'mores because we don't have enough graham crackers. So here, graham crackers will be the limiting reactant. It would be the reactant that it does not allow more products to be made. It is completely used up. Once we completely use all of our graham crackers and we make 12 s'mores, we're gonna have extra marshmallow and extra chocolate pieces. So marshmallow and chocolate pieces will be the excess reactant. Okay, they will be left over in a chemical reaction. So limiting reactant is the reactant that produces the least amount of product. The excess reactant, we're gonna have extra of it. Okay, so let me give you another example. Making a bike. So in order to make a bike, we need 1 frame, 2 wheels to produce 1 bike, right? This 1 frame and 2 wheels, these would be our reactants. Okay, the bike will be the product. Remember that in reactants, we're always going to have a limiting reactant and an excess reactant. So let's say we have 100, big one paper. Let's say we have 100 bike frames. If we have 100 bike frames, we can make 100 bikes. If we have 250 wheels, each bike requires 2 wheels. So if we have 250 wheels, that means that we're going to be able to make 125 bikes. Okay, so even though we have enough wheels to make 125 bikes, we only have 100 bike frames. So we can only make 100 bikes. So once we make that 100 bikes, we're done. We cannot produce any more bikes. Okay, so here the bike frames are going to be the limiting reactant or reagent, because that's what's going to, once we use all of this, that's it. We don't have any more. We cannot make any more wheels, any more bikes. Wheels are going to be our excess reactant. Okay, there's going to be extra wheels. There's going to be 50 extra wheels, because with 250 wheels, we were going to be able to make 125 bikes, but we only made 100 bikes. So that means that we made 25 less bikes according to the wheels. Each bike requires 2 wheels, so we would have 50 extra wheels. To calculate the limiting reactant, there's 2 steps that we always have to take. One, we're always going to convert the grams of each reactant to grams of one of the products. Okay, so we're going to choose one product, and we're going to convert grams of each reactant to grams of one of the product. Step 2 is you're going to compare the grams of the products from each. Whichever gives you the less product is a limiting reactant. So whichever reactant gives you the least amount of product, that would be the limiting reactant. Okay, so an example of limiting and excess reactant is this. If 6 moles of HF is added to 4.5 moles of SiO2, which is the limiting reactant. So in this case, they give us 2 information. They give us that we have 6 moles of HF, and they also tell us that we have 4.5 moles of SiO2. Okay, so I need to convert each of these moles into grams of one of these products. Okay, it doesn't matter which product I choose, I just have to choose one and solve for that one. So let's say I choose to solve for water. Okay, if I choose to solve for water, I'm going to start with what was given to me. Okay, I'm going to start with what was given to me. I'm going to start looking at SiO2. Okay, so based on SiO2, if I add 4.5 moles of SiO2, I'm going to do the same thing that I've been doing all along. I'm going to go from one compound to another. Okay, so I need to see if I have 4.5 moles of this, how much water can I produce if I have 4.5 moles? Okay, if I have 24 graham crackers, how many s'mores can I make? So how much product can I make? So I'm gonna do the same thing that I've been doing before. I always need to use the mole ratio. In this case, I'm already in moles, so my next step is to use my mole ratio of 1 mole of SiO2 for every 2 moles of water. Okay, my moles of SiO2 are gone. Now I can go to grams. I know that in the previous section I said that we had to go to grams of the product, but for this specific example, I'm going to stop here. Okay, I'm going to stop in moles, because all this question is asking me is about the limiting reactant. So if it's just asking me about the limiting reactant, I'm just going to stop in moles. Okay, so I'm going to do 4.5 times 2 divided by 1, and I produce 9 moles of water. So SiO2 produces 9 moles of water. So now I need to do the same thing, but looking at my 6 moles of HF. So now looking at HF, I have 6 moles. I need to see how much product do I produce, or can I produce. So since I'm already in moles, my next step is to use a mole ratio. 4 moles of HF for every 2 moles of water. 2 moles of H2O. The moles of HF cancel out. I'm going to get my calculator, multiply 6 times 2, 12, divided by 4, and that gives me 3 moles of water. So this HF produced 3 moles of water. Okay, so who is my limiting reactant? Is it HF or is it CiO2? Which produced the least amount of product? HF. So HF is the limiting reactant, and that's my final answer. HF is the limiting reactant. Therefore, SiO2 is the excess reactant. Okay, and that's it. So we just have to pick one of the product and solve each reactant, solve for that product, and just see whoever produced the least amount of product, that is a limiting. Whoever produced the most amount of product, that is the excess. That means that we're gonna have left over of them. Let me stay in this problem and let me just do something. Let's say instead of water, okay, because you guys get to choose which product you solve for. Let's say that instead of solving for water, I solve for this one, SiF4. Okay, so instead of solving for water, like I did in the previous problem, okay, that I was solving for water, I now solve for SiF4. Same thing. I'm going to get each reactant and solve for the same product. So looking at SiO2, I have 4.5 moles of SiO2. Since I'm already in moles, I'm going to use a mole ratio. So I have 1 mole of SiO2 for every 1 mole of SiF4. Moles of SiO2 cancel out. I multiply 4.5 times 1 divided by 1. It gives me 4.5 moles of SiF4. So silicon oxide produces 4.5 moles of silicon fluoride. Now I'm going to do the same thing but looking at HF. So I'm going to get 6 moles of HF and convert it to moles of silicon fluoride. So according to my mole ratio, I have 4 moles of HF for every 1 mole of SiF4. Moles of HF cancel out. I'm going to multiply 6 times 1 divided by 4, and it gives me 1.5 moles of SiF4. So that means that HF produces 1.5 moles of SiF4. Which of the 2 reactants produced the least amount of product? This is the least. That means that HF, because HF produced this much product, HF is the limiting reactant, and SiO2 is the excess. SiO2 is the excess reactant. Okay, so in this type of problem, they're going to give you how much of each reactant you have, and you have to predict, or not predict, but you need to calculate which is going to be the limiting and which is going to be the excess. And you do that by choosing one of the product and solving for it. It doesn't matter which one you choose. In this case here, I solved for SiF4. My limiting reactant was HF. In this case, I solved for water. my limiting reactant was still HF. So it doesn't matter which one I use, which product I use, my answer, my limiting reactant is going to be the same.